Look at this image. A family, smiling, captivated by the otherworldly blues and oranges of a Yellowstone hot spring. They are standing just a few feet away, on what looks like solid ground, separated only by a simple wooden railing. It seems safe. It seems permanent. But what they don't know, what millions of visitors to this incredible park don't fully comprehend, is that the ground they're standing on isn't solid at all. It is a paper-thin, fragile crust. A brittle lid of mineral deposits formed over millennia, sitting directly on top of a plumbing system filled with boiling, often acidic, water. In many places, this crust is the only thing separating the crisp mountain air from a subterranean world of immense pressure and superheated steam. They are standing on the lid of a geological pressure cooker, and sometimes those pressure cookers explode. Before we pull back the curtain on this hidden danger, I need to ask you something. What is the most powerful force of nature you have ever witnessed with your own eyes? A thunderstorm, a blizzard, a crashing wave? Let me know in the comments below, because the forces we are about to explore are of a completely different magnitude, operating just out of sight. And one more critical thing. An enormous number of people who watch our documentaries and tell us they love them forget to subscribe. For an independent channel like ours, that is an emergency. It directly impacts our ability to fund and create these deep investigations. So, if you value this kind of content and you want to ensure we can keep making it, please take one single second and press the subscribe button right now. It is vitally important, and it's the number one way you can support what we do. Do it now, please. Now, let's begin. When most people think of danger in Yellowstone, their minds immediately leap to one thing: the supervolcano, the apocalyptic caldera-forming eruption that lives in the public imagination. But scientists, the very people who monitor this system 24/7, will tell you that this is not the hazard to worry about on a human timescale. The Yellowstone Volcano Observatory, or YVO, the joint partnership between the U.S. Geological Survey, the University of Utah, and the Park Service, states unequivocally that the odds of such an eruption in any given year are about 1 in 730,000. For comparison, your odds of being struck by lightning in your lifetime are about 1 in 15,300. So while the supervolcano gets the headlines, the real, present, and documented danger is far more intimate, and in many ways far more terrifying. It is the water, the beautiful, steaming, mesmerizing water. Since Yellowstone was established as a national park in 1872, more than 20 people have died from incidents involving these thermal features. The cause of death is almost always the same: severe burns from falling into water that is at, or in many cases, well above the boiling point. At Yellowstone's high altitude, water boils at around 199 degrees Fahrenheit, or 93 degrees Celsius. Many of the pools are much hotter. This is because the water is what's known as superheated. Deep underground, thanks to the immense heat radiating from the magma chamber miles below, the water is under such intense pressure that it remains in a liquid state at temperatures far exceeding its normal surface boiling point. When it rises to the surface and that pressure is released, it does so with explosive energy. But it's not just the heat. Depending on the plumbing, the water can also be incredibly acidic. Volcanic gases, primarily hydrogen sulfide, bubble up from the depths and dissolve into the groundwater, creating sulfuric acid. In some areas, particularly the mudpot basins, the water's pH can drop to between 1 and 3, making it as acidic as stomach acid or even battery acid. This combination of extreme heat and potent acidity creates a lethal environment that most visitors only glimpse from the safety of the boardwalks. The boardwalks themselves are a testament to this danger. They are not there for convenience. They are a critical lifeline. They are built over ground that is often hollow, unstable, and treacherous. The vibrant, colorful rings around features like the Grand Prismatic Spring are formed by colonies of thermophilic bacteria. But the ground they live on is a delicate center crust, precipitated out of the silica-rich water over centuries. In some places, this crust can be as thin as a dinner plate. Stepping off the designated path is a gamble with horrifying stakes. In 2016, this gamble ended in the ultimate tragedy. A 23-year-old man from Oregon, Colin Scott, left the boardwalk in the Norris Basin with his sister, looking for a place to do something called hot potting, illegally swimming in a thermal pool. As he reached down to test the temperature of a spring, he slipped and fell in. Rescuers who arrived shortly after could see his body in the churning acidic water, but a severe lightning storm forced them to suspend their recovery efforts. When they returned the next day, there was nothing left to recover. The combination of the heat and the acid had completely dissolved his body overnight. As Deputy Chief Ranger Laurent Varus grimly stated, they were looking for a place to hot pot in what he called a very dangerous environment. The incident is a brutal, sobering reminder that the park's rules are not arbitrary. They are written from a long and tragic history of underestimating the power boiling just beneath the surface. This is the most immediate danger in Yellowstone, the risk of falling in. But there is another, related hazard, one that doesn't require a person to make a mistake. A hazard where the danger comes to you. It's what happens when the very ground beneath your feet can no longer contain the pressure building below. This is the world of hydrothermal explosions. Imagine being there, standing on the boardwalk at Pork Chop Geyser in the Norris Geyser Basin. One moment you're watching a gentle, continuous spouter. The next, with a deafening roar, rocks the size of fists are flying through the air. What would your first reaction be? Freeze in place, turn and run, or pull out your phone to film? Let us know what you'd do in the comments. This isn't a hypothetical. It really happened. A hydrothermal explosion is fundamentally different from a volcanic one. There is no magma involved. Instead, it is a steam-driven event. Think of it like a steam cannon or an overpressurized boiler failing catastrophically. The process begins deep within Yellowstone's complex underground plumbing. Rainwater and snowmelt seep down through cracks in the rock, sometimes for miles, down there. The water is heated by the deep magma source to a superheated state. As it rises, it should flash into steam, but the immense weight of the overlying rock and water keeps it trapped in its liquid state. The system is a delicate balance of heat and pressure. But if that pressure is suddenly released, the result is instantaneous and violent. The superheated water flashes into steam, expanding to more than 1,500 times its original volume in a fraction of a second. This explosive expansion shatters the surrounding rock and hurls a terrifying mixture of steam, boiling water, mud, and rock fragments high into the air. What can trigger such a sudden pressure drop? There are a few culprits. A strong earthquake can fracture the rock, creating new pathways for the pressure to escape. A sudden change in the water table could also be a factor. But one of the most common triggers is the system sealing itself. The same silica that creates the beautiful center crusts around geysers can also build up inside the underground channels, slowly clogging the plumbing like cholesterol in an artery. The pressure behind this seal builds and builds until the rock cap can no longer contain it. Then, failure is catastrophic. This is exactly what happened on September 5th, 1989, at Pork Chop Geyser. Before that day, Pork Chop was a relatively unassuming feature in the Norris Geyser Basin. It was a perpetual spouter, splashing water a few feet into the air, more of a bubbling pool than a true geyser. But beneath the surface, minerals were slowly sealing its vent. For weeks leading up to the event, park rangers had noticed changes. The geyser's activity had waned, a sign that the system was becoming choked. Then, on that Tuesday morning, the seal broke. With an explosive roar, Pork Chop Geyser detonated. It blasted a crater more than 15 feet across and threw rocks, some weighing over 100 pounds, more than 217 feet away. Boulders landed on the nearby boardwalk, shattering the wooden planks. Had tourists been standing where they normally did just moments before, the consequences would have been deadly. The area was immediately closed, and for months after, the new larger crater violently steamed, a raw wound on the landscape. Pork Chop Geyser showed the world how a seemingly quiet hot spring could become a lethal projectile launcher with almost no warning. And these aren't exceptionally rare events. According to the USGS, small hydrothermal explosions that create craters a few feet across happen, on average, every 1 to 2 years somewhere in the park. They often occur in the backcountry, away from visitors, and go unnoticed until a geologist stumbles upon a fresh crater and a swath of downed trees. They are a routine, if violent, part of Yellowstone's natural cycle. But the potential for them to occur in the park's busiest areas is always there. This knowledge transforms how you see the landscape. You begin to understand that the entire geothermal basin is a potential pressure zone. This is a level of natural power that can genuinely keep people safe to know about. If you know anyone, a friend, a family member who dreams of visiting a place like Yellowstone, or if you simply think this story is worth sharing, please do us a huge favor, hit the like button so more people see this, and use the share button to send it to them. Spreading this awareness is a massive help, both to them and to our channel. The explosive potential of Yellowstone's hydrothermal system is inextricably linked to the immense geological engine that drives it. To understand the risk, we have to zoom out and look at the entire caldera, which is essentially the footprint of the last super eruption 631,000 years ago. The entire park sits atop a massive active magma chamber. While this magma isn't going to erupt anytime soon, its heat is the primary energy source for all 10,000 of Yellowstone's hydrothermal features. It is the fire under the boiler, and this entire system is alive. It moves. It has a heartbeat, and it breathes. The heartbeat of Yellowstone is its constant seismic activity. The region experiences between 1,000 and 3,000 earthquakes every year. The vast majority of these are microquakes, too small for a person to feel. They occur in swarms, clusters of dozens or even hundreds of small tremors over days or weeks. These are not precursors to a volcanic eruption. Rather, they are the sounds of the active system, rocks shifting along fault lines, and pressurized water moving through the underground plumbing. It is the creaking and groaning of a massive, geologically active machine. But this machine also breathes. Using a network of high-precision GPS stations, scientists at the YVO have measured the entire floor of the Yellowstone caldera, rising and falling over time. Between 2004 and 2010, an area stretching for miles across the caldera floor rose by as much as 10 inches. The ground was literally swelling upwards. This was caused by a combination of a small amount of new magma intruding into the deep chamber, and more significantly, the expansion of the vast hydrothermal fluids trapped above it. Then, just as mysteriously, the trend reversed, and the ground began to subside. This cycle of uplift and subsidence is what geologists call breathing. It's a physical manifestation of the immense pressures shifting and redistributing miles beneath the surface. And we have dramatic historical proof of how sensitive this pressurized system is to being disturbed. On the night of August 17, 1959, the ground just west of Yellowstone National Park was ripped apart by a powerful magnitude 7.3 earthquake, the Hebgen Lake earthquake. The shaking was so violent it triggered a massive landslide that dammed the Madison River, creating a new lake and tragically killing 28 people. Inside the park, the effects were instantaneous and profound. The earthquake was like a giant hand that violently shook Yellowstone's entire plumbing system. Overnight, the park's hydrothermal features went haywire. Geysers that had been dormant for decades roared to life. Others, like the famous Old Faithful, had their eruption intervals dramatically altered. Hot springs that were once crystal clear turned muddy and turbid as the seismic waves churned up sediment from their depths. New cracks, called fumaroles, opened in the ground, hissing superheated steam into the air. One of the most violent transformations happened at Sapphire Pool in Biscuit Basin. Before the quake, it was a beautiful, placid blue pool, surrounded by unique, biscuit-like sinter deposits. The earthquake turned it into a raging geyser. It erupted violently, blasting away its namesake biscuits and blowing out a crater more than double its original size. The 1959 earthquake provided undeniable proof that a major seismic event can instantly and unpredictably reconfigure the hydrothermal hazards across the entire park, potentially triggering new and violent explosions. Alright, I know I've mentioned it once, but I'm looking at our analytics and a shocking percentage of you watching right now still haven't subscribed. Come on, don't make me use the park ranger voice. Hitting that subscribe button is, without question, the single best way to ensure we can launch our next investigation. It takes one click. I'll wait. Alright, awesome. Thank you. Now back to the day the Earth literally shook Yellowstone's plumbing to its core. The changes wrought by the Hebgen Lake quake highlight the most dynamic and dangerous thermal area in the park, Norris Geyser Basin. Norris is the oldest, hottest, and most acidic of Yellowstone's major geyser basins. It sits at the intersection of three major fault lines, making it a natural weak point in the Earth's crust. It is a place of constant change. In the summer of 2003, the basin experienced what scientists termed a thermal disturbance. Ground temperatures in some areas soared to near boiling, reaching 201 degrees Fahrenheit or 94 degrees Celsius. New mud pots bubbled up from the forest floor, killing trees from the roots up. Steamboat Geyser, the world's tallest active geyser, is located here. For decades, it was mostly dormant, with major eruptions being rare, once-in-a-decade events. But in 2018, it roared back to life, entering a new phase of unprecedented activity. It began erupting dozens of times a year, with 48 eruptions recorded in both 2019 and 2020. These powerful eruptions can shoot water over 300 feet into the air, a display that reminds us of the raw power lurking beneath. Norris, the reactivation of Steamboat, is yet another sign of the system's inherent unpredictability. This is why Norris is one of the most intensely monitored places on the planet. The explosion at Porkchop Geyser in 1989 was a frightening demonstration of what a small sealed feature can do. But it is nowhere near the upper limit of what Yellowstone's steam power is capable of. To see that, you only need to look at a map of Yellowstone Lake. On its northern shore is a wide semicircular indentation called Mary Bay. To the casual observer, it's just a scenic bay, a pretty place to watch the sunset over the water. But Mary Bay is not a bay. It is a scar. It is a 1.5-mile wide crater, the result of a massive hydrothermal explosion that occurred approximately 13,800 years ago. The scale of this event is difficult to fathom. An area of land a mile and a half across was instantaneously shattered and excavated, not by magma, but by flashing steam. The energy release would have been equivalent to a substantial nuclear detonation. It would have sent a plume of rock, mud, and superheated water miles into the sky, raining debris over hundreds of square miles. It is the largest known hydrothermal explosion event in the world, and it is not alone. Elsewhere in Yellowstone, geologists have identified other massive prehistoric explosion craters. Pocket Basin is roughly 2,000 feet across. The crater that now holds Turbid Lake is nearly a mile wide. These are not ancient volcanic calderas. They are the remnants of monster steam explosions which Dr. Michael Poland, the scientist in charge of the YVO, refers to as a significant and underestimated hazard. The USGS is clear about the likelihood of these events. They state that larger explosions, which could create craters a few hundred meters across and pose a threat to anyone within a kilometer or two, probably occur on a timescale of every few hundred to few thousand years. We may not be due for another Mary Bay-sized event tomorrow, but the potential for a pork-chop-scale explosion, or something significantly larger, happening in a developed area, is a real and constant concern for park management and scientists. This is why the YVO's work is so critical. They are not just watching for a supervolcano, they are running the world's most advanced geological health monitoring system. This system relies on a network of seismometers to detect the heartbeat of earthquakes, GPS stations to measure the breathing of ground deformation, and gas sensors to sniff the air for changes in volcanic gas emissions. More recently, they have employed cutting-edge technology to peer beneath the ground. Airborne missions using thermal infrared imaging can map out hotspots across the entire park, revealing areas where heat is anomalously high, even in places with no visible surface features. They also use a technique called airborne electromagnetics. By flying a large loop of wire that generates an electromagnetic field, they can map out the electrical conductivity of the ground below. Hot, mineral-rich water is a much better conductor of electricity than solid rock. This allows them to create a 3D map of Yellowstone's subterranean plumbing, highlighting where superheated water is being trapped, the very areas that are the most likely candidates for future hydrothermal explosions. A 2021 study even used advanced computer modeling to confirm that changes in the level of Yellowstone Lake, coupled with seismic activity, are key factors in triggering these large explosions, connecting climate, geology, and hazard in a deeply intricate web. The incredible scientists at the Yellowstone Volcano Observatory are dedicated to this constant, vigilant monitoring. And I am dedicated to reminding you one last time to subscribe to this channel. Okay, that's it. I'm done now, I promise. Probably. But in all seriousness, thank you from the bottom of my heart to every single person who has subscribed. It means the world to us. All of this research, all of this monitoring, leads back to the same fundamental truth. The ground in Yellowstone is alive, and it is unpredictable. The stunning beauty of the geysers and hot springs is the direct result of a violent, high-pressure system that is constantly seeking a way to release its energy. The boardwalks and the park rules are the only things that stand between millions of visitors a year and a hazard that can scald, dissolve, or violently explode with very little warning. We are drawn to Yellowstone because it offers a window into a different world, a primal world of geological power. We stand at the edge of pools, colored with impossible blues and greens, and watch steam rise into the cold air. And we feel a sense of awe, but it is crucial to temper that awe with a deep and abiding respect for the forces at play. Those smiling tourists in the picture, standing by the railing, are enjoying one of the great wonders of the natural world. But they are also standing closer than they will ever know to an invisible danger line. They are on the edge of a zone where the Earth itself can no longer be trusted, where solid ground is an illusion, and where the stunning beauty is just the surface expression of a power that can, and does, tear the world apart from below. The real threat isn't some distant cinematic super eruption. The real threat is right there, steaming quietly, just a few feet away.